Ever wondered how data travels across the internet and what makes it all possible? Curious about the layers that handle your emails, websites, and more? If so, you're in the right place. Welcome to WhiteboardDoodles, the channel where we simplify tech-related concepts using whiteboard animations. Today, we're diving into the OSI model, the backbone of internet communication. By the end, you'll grasp how each layer contributes to keeping our digital world running smoothly. Let's get started. First, let's take a look at what the OSI model is. The OSI model, or Open Systems Interconnection Model, is a framework used to understand and standardize how different network protocols interact to enable communication over a network. It divides network communication into 7 distinct layers, each with specific functions and responsibilities. These layers are physical, data link, network, transport, session, presentation, and application. Each layer serves a unique role, from transmitting raw data bits over hardware to providing end-user services like web browsing. By breaking down network communication into these layers, the OSI model helps ensure interoperability and simplifies troubleshooting and design in networking. Let's analyze each layer individually. Number 1. The physical layer. The physical layer is the first layer of the OSI model and is responsible for the transmission and reception of raw binary data over physical media. It deals with the hardware aspects of networking, such as cables, switches, and network interface cards, ensuring that data is converted into signals that can be sent over various types of physical connections, including electrical, optical, or radio waves. For example, when you connect your computer to a router using an Ethernet cable, the physical layer handles the actual transmission of data bits through the cable. It defines the specifications for devices, including the type of cables, connectors, and signal types used, as well as how data bits are encoded and transmitted. Essentially, the physical layer provides the foundation upon which the higher layers build their functionality, enabling the physical connection between devices on a network. Number 2. The data link layer. The data link layer is the second layer of the OSI model and is essential for transmitting data across a network. It takes raw data from the physical layer and organizes it into frames, which are structured packets of information. This layer handles addressing and error detection to ensure that data reaches the correct device and any transmission errors are managed. For example, imagine you're sending a document from your laptop to a printer over a local network. The data link layer adds a header to the data frame, including the printer's MAC address, so the document is delivered to the right device. MAC addresses are critical on this layer as they help identify devices uniquely on a network. For a more detailed explanation of MAC addresses, check out our separate video on that topic. It also controls the data flow to prevent collisions, making sure the transmission is smooth and efficient. In essence, the data link layer makes sure data is properly packaged and accurately delivered within a local network. Number 3. The network layer. The network layer is the third layer and is crucial for routing data across different networks. It takes the data frames from the data link layer and adds logical addressing, such as IP addresses, to help route the data to its destination across various networks. For example, when you send an email from your computer to someone across the globe, the network layer determines the best path for the data to travel through different networks and routers. It handles packet switching and routing, ensuring that data is directed efficiently from the source to the destination. The network layer also manages traffic congestion and can split large data packets into smaller fragments if needed. Essentially, it directs data traffic across multiple networks to ensure it reaches the correct location. IP addresses play a key role in this process by identifying devices and guiding the data flow. For an in-depth look at IP addresses, be sure to check out our separate video on that topic. Number 4. The transport layer. The transport layer is the fourth layer and is crucial for managing the end-to-end delivery of data across networks. It takes the segments from the network layer and ensures they are transmitted reliably between devices. For instance, when you make a video call, the transport layer breaks the data into smaller chunks, sends them to the recipient, and ensures they arrive in the correct order and without errors. It handles tasks like error correction, retransmitting any missing or corrupted pieces of data to guarantee a smooth and uninterrupted call. Additionally, the transport layer manages data flow to prevent congestion and ensures that the data transfer rate is appropriate for both sending and receiving devices. Key technologies at this layer include protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, which provide the mechanisms for reliable or fast connectionless data transmission respectively. Number 5. The Session Layer. The session layer is the fifth layer of the OSI model and is responsible for managing and controlling interactions between applications. It establishes, maintains, and terminates communication sessions between two devices on a network. For instance, when you're using a video conferencing app, the session layer manages the connection between your device and the other participants' devices, ensuring that the session remains active and organized. It handles tasks such as session establishment, synchronization, and recovery from interruptions. If the connection is temporarily lost, the session layer can help reestablish it without losing the current state of the communication. Technologies at this layer include session management protocols like NetBIOS and RPC, Remote Procedure Call, which facilitate session setup and coordination. Number 6. The Presentation Layer. The presentation layer is the sixth layer of the OSI model and plays a crucial role in translating and formatting data for the application layer. It is responsible for data translation, encryption, and compression, ensuring that data is presented in a format that the application layer can understand. For example, when you open a file in different software applications, the presentation layer converts the file data into a format that the application can process, whether it's text, images, or video. It handles tasks such as converting data from one character encoding to another, compressing data to reduce transmission size, and encrypting data for security purposes. Technologies at this layer include data formats like JPEG for images or MPEG for video, and encryption protocols like SSL and TLS for secure data transmission. And number 7. The Application Layer. The application layer is the seventh and topmost layer of the OSI model and is directly responsible for providing network services to end-user applications. It is the layer where users interact with network services and applications, such as web browsers, email clients, and file transfer programs. For example, when you use a web browser to access a website, the application layer handles the interaction with the web server, interpreting and presenting web data in a user-friendly format. It provides essential services like email transmission, file transfer, and web browsing. Technologies at this layer include protocols and services that enable specific applications, such as HTTP for web pages, SMTP for email, and FTP for file transfers. Essentially, the application layer ensures that user applications can effectively communicate over the network and provides the interface between the network and the end-user applications. Now that we've covered all the layers of the OSI model, let's walk through an example to see how a data packet travels through each layer during a typical web browsing session. Imagine you are using your web browser and typing in the URL for YouTube. At the application layer, the browser uses the HTTP protocol to generate an HTTP request to fetch the web page from YouTube. Next, at the presentation layer, the HTTP request is formatted and encoded, often using SSL and TLS for encryption to ensure secure communication. As the request moves to the session layer, a session is established between your browser and the YouTube server, managing the interaction throughout the session. At the transport layer, the HTTP request is divided into segments, which are managed by TCP or UDP, depending on the protocol used, to ensure reliable data transfer. Each segment is then encapsulated into packets at the network layer, with an IP address assigned to route the packets to the YouTube server. On the data link layer, the packets are further encapsulated into frames for transmission over the local network. This layer handles addressing with MAC addresses and ensures proper frame delivery on the local network segment. Finally, at the physical layer, the data frames are converted into electrical signals, optical signals, or radio waves, depending on the network medium, and transmitted over the network using cables, fiber optics, or Wi-Fi. This concludes our exploration of the OSI model. If you enjoyed it, consider subscribing to our channel and liking the video. Feel free to also check out our other videos on related topics. Thank you for watching.